In this video, the topic to be discussed is McLaurin series. And what does McLaurin series say? That when we have a function f of x, this can be written in series form as f of 0 plus f prime of 0 x, f second derivative evaluated as 0 of the function divided by 2 factorial x squared plus the third derivative of the function evaluated at 0 over 3 factorial x cubed plus higher order terms. So it's a very important achievement because we can express a function as a polynomial. We can write this as a0 plus a1 of x plus a2 x squared, a3 x to the power of 3 plus higher order terms. We can write a function as a polynomial where the coefficients involve the function and its derivatives. Now we will see how this comes into play. Let's take this polynomial plus an x to the power of n. Let's calculate the first derivative with respect to x. That's a1 plus 2a2 x plus 3a3 x squared plus an x to the power of n minus 1. Let's evaluate the function at 0. f of 0 is a0. Now f prime of 0. If I put in this expression x equal to 0, I just have a1. F double prime of x is what? The derivative of a constant function is 0. Then I just have 2a2 plus 6a3x plus n minus 1 an x to the power of n minus 2. I evaluate the second derivative of the function, a polynomial function, at 0. So all the terms disappear and only the 2a2 remains here. So from here I have that a2 is second derivative evaluated at 0 over 2. Let's calculate the third derivative of the function. If I calculate the third derivative of the function, this term here will vanish and I will just have 6a3 plus the other terms plus n minus 1, n minus 2, x n minus 3. Evaluate that the third derivative of 0. All the terms will vanish except this one, so I have 6a3, and from here a3 should be third derivative evaluated at 0 over 6, and that can be written as 3 factorial. So my coefficient a3 is the third derivative of the function evaluated at 0 over 3 factorial. So my polynomial was f of x equals a0 plus a1x plus a2x squared plus a3x to the power of 3 plus an x to the power of n. What is a0? a0 is f of 0 plus the a1 is the first derivative evaluated at 0 times x plus the coefficient of the polynomial a2 is the second derivative evaluated at 0 over 2 factorial x squared, plus a third coefficient here is the third derivative evaluated at 0 over 3 factorial x3, plus fn evaluated at 0 over n factorial x to the power of n. So in general I can write f of x as a power series from j equals 0, from k equals 0 to n, f kth order derivative evaluated at 0 over k factorial x to the power of k. And if I want, this is truncated at when I have n terms, I can write it as a power series, sum from k0 to infinity, f k, kth order derivative evaluated at 0 over k factorial times x to the power of k. It means, again I repeat, that f of x is the sum from k equals 0 to infinity fk 0 k factorial x to the power of k. I can represent the function as a power series, and the coefficients of this series, the coefficients are involving the function and its higher order derivative. So I have a function expressed as a polynomial where the coefficients of this polynomial involve the value of the function at some point x0 and the higher order derivatives. It's a really important tool because any analytic function means that we can express it in some form of power series, and this McLaurin series are approximations of the function at certain neighborhoods of x, and these are really important functions. Another approximation that you could have is PADE approximations, where you can express the function as a rational function of polynomials, some polynomial in the numerator and some polynomial in the denominator. But here we stick to the McLaurin expansion, McLaurin series expansion. I will make a video about finding a McLaurin series of exponential function with a variable base.